this example, we're going to compute a to the power of 5. First, we need to find the eigenvalues for the eigendecomposition. So a minus lambda I here is going to be 0 minus lambda is negative lambda, then 2, then 2, then 3 minus lambda. So our determinant of negative lambda, 2, 2, 3 minus lambda, this determinant is 0. So we've got negative lambda, 3 minus lambda, minus 4 equals 0. And so that's lambda squared minus 3 lambda minus 4. And if we factor this, we get lambda minus 4, lambda plus 1. Okay. And so our lambda is equal to 4 or negative 1. Now, when lambda is equal to 4, if we look at our a minus lambda I, we've got negative 4, 2, 2, 3 minus 4 is negative 1. This times xy has to be 0 because a is equal to ax is equal to lambda times x. So as a result of this, you can see that this gives us a system of equations 2x is equal to y. And so we get the eigenvector x is equal to 1, y is equal to 2. That satisfies this equation. When lambda is equal to negative 1, our matrix becomes, our a minus lambda I matrix becomes 1, 2, 2, 3 minus 1 is 4. And so here, x is equal to negative 2y, or negative x is equal to 2y. And so we get the eigenvalue, y is equal to negative 1, x is equal to 2. Great. So we've got our two eigenvalues. We've got our two eigenvectors. And so we can compute our PD and P inverse. So first, our P is formed with the eigenvectors as columns. So 1, 2, and then 2, negative 1. D has the eigenvalues along the main diagonal in the same order. Good. And P inverse. So we've got negative 1 minus 4 is negative 1/5 times negative 1, negative 2, negative 2, 1. And so if you multiply these together, you get A equals PDP inverse. And that's the eigendecomposition for A. Now, if we want to compute A to the 5th, this is A multiplied by itself 5 times. which is the same as PDP inverse multiplied by itself 5 times, which seems like 3 times as many multiplications. But when you actually expand it out, our P's and our P inverses cancel out, and you actually simplify this to become P d to the power of 5 P inverse. And we've got P here, we've got P inverse, d to the power of 5, because it's a diagonal matrix, you can just exponentiate the diagonal elements. So 4 to the power of 5, 0, 0, negative 1 to the power of 5 is negative 1. And so a to the power of 5 is going to be P times this matrix here times P inverse. And that's going to be a way to compute a to the power of 5 by multiplying 3 matrices rather than multiplying 5, which is going to save us a little bit of time.